Welcome to the deep dive. Today we're jumping into something really crucial for anyone actually using AI models day to day. It's about making smart choices, thinking beyond just, the biggest number or the rawest power. The main question we're tackling is this. Is GPT-5 Mini really the best dollar for dollar choice for most teams out there? Think of this as a shortcut, a way to get straight to the heart of where the real value lies in the current AI landscape. It's pretty dynamic right now. Our source material is an independent benchmark deep dive. It's titled GPT-5 Mini, The Best Value in AI by ASMAT, published just recently, August 11th, 2025. So our mission today is to pull out the key insights, the real nuggets about value, performance, and how this stuff actually applies in practice. We want you to walk away feeling really clear on this.
Right. And for those of us who actually ship products using these language models, benchmarks are useful. They give you context, but they're kind of like weather reports, right? Helpful, but not the whole picture. What really matters at the end of the day, it's the bill. Demos look great, sure, but being on call when something breaks at 2 a.m., not so much fun. The models that actually stick around, the ones that last in production, they tend to share three things. One, they think clearly, especially when you frame the task well. Two, they respect your budget. And three, the latency is low, like low enough that users aren't sitting there drumming their fingers. And GPT-5 Mini, it really seems to live in this sweet spot. Capability, latency, price, they all kind of align. It's almost like a tuned hatchback that somehow keeps slipping past supercars and heavy traffic. It just works surprisingly well for what it costs.
Okay, that's a great analogy. So just to set the scene, where exactly does GPT-5 Mini fit in OpenAI's lineup? What's its basic setup?
Yeah, it's positioned quite strategically. It sits right below the main flagship, GPT-5, but above the smaller GPT-5 Nano. What you get with Mini is actually a pretty long context window. That's important. It means you could paste in whole spec documents, multi-file code diffs, long research notes, without needing to chop everything up into tiny pieces.
Okay, so less pre-processing hassle.
Exactly. And the latency is low enough that you can build genuinely interactive products on top of it. Plus, the price for output tokens, it's really small. You can run big batches without constantly worrying about the cost meter spinning. This enables what the source calls a layered design.
Layered design.
Yeah, because the pricing allows it. You can route your really high-stakes, sensitive queries to the big GPT-5 model, then the bulk of your everyday traffic. That goes to Mini, and maybe background tasks like data enrichment. Push those to Nano. This kind of clean split, it directly leads to calmer budget reviews, and everyone wants those.
I can imagine fewer awkward conversations about the cloud bill.
Precisely. And practically speaking, this really changes how teams plan their work. When you know the cost per request before you start coding, you can actually promise to ship, say, a thin slice of a feature within the same sprint. You have that cost certainty.
Right.
The model speed keeps the UI feeling responsive, keeps it lively, and its capacity, well, it helps keep the support tickets down because it handles the load well. So your backlog starts looking less like a list of risky model experiments and more like a solid plan of actual improvements you can ship to users.
That feels like a really significant shift in how teams can operate. But, there's often this reflex, especially for engineers, to just grab the biggest, most powerful model available.
So what's fundamentally changed? Why can a smaller model actually be better, sometimes even preferable, if the task is framed well? Is there a common mistake people still make here? Yeah, that reflex made a lot more sense back when model size and performance basically marched in lockstep. Bigger was just always better.
Yeah.
But it's just not the whole story anymore. Things like instruction tuning, how well a model uses tools, smart routing these factors matter just as much now, maybe even more sometimes. If you scope a task clearly, a more compact model that has strong reasoning can actually outperform a giant model that tends to, wander or give you way more than you asked for. GPT-5 Mini, the source says, it rewards clarity.
Rewards clarity. I like that.
And it's not just a catchy phrase, it's what you actually see happen when you use it. The common pitfall. Still treating it like some kind of magic black box instead of a precise instrument that needs clear instructions.
Okay, so how do you give it that clarity? What are the concrete examples?
Right, so the source lays out a few things that really help Mini perform at its best. Define your output schema very precisely. Tell it exactly what structure you want back. Provide one really high-quality example for each tricky edge case you anticipate. And ask the model for a short, simple chain of steps. It can follow something you can easily check. The more explicit you are, the better it works. It's less about hoping it understands and more about telling it what to do.
Makes sense.
And this isn't just theory. It's backed up by the benchmarks they used. Things like AIME and Math 500, they specifically test symbolic reasoning, arithmetic. stuff that trips up weaker models.
Okay.
Then you got GPQA, which is about synthesis under pressure. MMLU Pro looks at depth across different fields. And MMMU, that one tests multimodal reasoning, understanding charts and figures. The key point is that Mini's performance on these benchmarks seems to line up really well with what people experience day-to-day in production. And that's exactly what you want if you're the one carrying the pager for the system. Reliability.
Absolutely. Okay, now this is where, for many listeners, the rubber really meets the road. Let's dig into those core numbers. How do these different models actually stack up when you look at accuracy, price, and latency together?
Right. This is crucial. The source pulls data from Table 1, frontier models, accuracy, and price on high-difficulty tasks. Let's unpack the patterns. GPT-5 Mini, it consistently hits accuracy in the high 80s, low 90s% range on tough benchmarks like AIME, GPQA, MMMU. Pretty solid.
Okay, high 80s, low 90s. That's good.
Yeah, very respectable. But here's the kicker. Its output cost is just $2 per million tokens.
$2.
$2. And latency is around 114 seconds. Call it just under 2 minutes. Now, compare that to the flagship, GPT-5. Okay, it nudges accuracy up a bit, maybe 2 to 5 percentage points, like 93.4% on AIME versus Mini's 90.8%.
A small gain.
A small gain, yes. But the cost, it jumps to $10 per million tokens.
Wow, 5 times more.
5 times more. And the latency, it nearly tripled to 292 seconds, almost 5 minutes. So you have to ask, for most everyday production tasks, are those few extra percentage points really worth 5 times the cost and 3 times the weight? Often, the answer is probably no.
Yeah, that trade-off seems pretty clear for a lot of use cases. What about the others in that table?
Good question. You got Grok 4 and Claude Sonnet 4. Both are priced at $15 per million tokens.
$15, so even more expensive.
Significantly more expensive than Mini,
Yeah.
Grok 4 shows strong GPQA accuracy, around 88%, but Claude Sonnet 4 is a bit lower generally on these benchmarks.
Yeah.
And their latencies are similar to, or sometimes even higher than, Mini's. Then at the other end, the really cheap end, you have Gemini 2.5 Flash, super fast 11 seconds, and super cheap, only $1.40.
Okay, that sounds appealing.
It is, but its reasoning accuracy takes a noticeable hit, especially on AM. It was down around 30%. And lastly, GPT-5 Nano is also $1.40, but it's much slower, around 241 seconds. So that points more towards background jobs. So the pattern is really clear. Mini gives you that near flagship accuracy, but without the flagship price tag or the long wait. And it offers much better reasoning than the super cheap, super fast options.
That comparison is really stark, and the source brings up this metric, cost per correct answer. That seems incredibly powerful. Have you seen teams actually struggle to adopt that metric? Maybe they're just so used to looking at the raw token prices. What's the usual pushback, and how do you get past it?
Oh, absolutely. Cost per correct answer is, I think, the metric that keeps everyone honest. But yes, there's often initial pushback. Teams are just used to optimizing based on those simple token price tables. They don't tell the whole story. The pushback is usually something like, but look, my token price is lower with Model X.
Yeah.
And the answer needs to be, okay, yes, but how many incorrect answers are you paying for with Model X? And how much does each retry or downstream error actually cost your business? This metric forces that conversation. It combines the output token price, the average number of tokens needed for a solution, and the model's accuracy on a relevant benchmark. It's not perfect, nothing is, but it's a much better shared yardstick for product engineering and finance than just arguing about token rates.
So it bridges that gap.
Exactly. Let's look at the sources, Table 2.
Yeah.
Estimated cost per correct answer across key benchmarks. Because this is really where Mini pulls away from the pack. Getting a correct answer on these tough benchmarks with GPT-5 Mini, it costs mere pennies, like 0.01 tels for AIME, 0.01 pounds for GPQA.
Wow, just over a cent.
Just over a cent per correct complex answer. Now compare that to Gemini 2.5 Flash. Remember, it was super cheap per token.
Yeah, so 30 cents.
Right. But because its accuracy is lower on these reasoning tasks, it actually costs more per correct answer. Often, double Minis cost like 0.031 del for GPQA.
So you pay less per token, but more for the right result.
Precisely. You're paying for more incorrect attempts, essentially. And even the big GPT-5 flagship, while very accurate, ends up being nearly 3 to 4 times more expensive per correct answer. It comes in around $0.055 for GPQA. Claude Sonnet 4. By far the most expensive on this metric, almost 10 cents per correct answer on some benchmarks. So the data really highlights Mini's efficiency. It's about converting your dollars into correct, useful results at scale. That's the number an executive is going to remember from your budget review. not the token price.
That's a really compelling case for Mini's overall value proposition. So,
Yeah.
okay, if someone's listening and trying to decide which model to use for a specific feature, how does Mini stack up against its main rivals in different real-world scenarios?
Yeah, the source gives a good outcome-focused comparison.
Yeah.
Gemini 2.5 Flash, like we said, is built for speed. So it's great for things like instant summaries, quick data extractions, maybe large-scale backfills where occasional error is, cheap to fix or tolerate.
Okay, high volume, lower stakes.
Yeah.
Exactly. Definitely not your choice for high-stakes reasoning tasks. Claude Sonnet 4 is described as more of a steady writer, a careful listener. It excels at following instructions precisely, has broad knowledge, good for maybe drafting content or detailed instruction following, but it is pricier, and the benchmarks suggest Mini often edges it out on math-heavy stuff or research synthesis, giving you better value there. Then there's Grok 4. Its strength seems to be pushing through really long, complex reasoning chains with quite a bit of confidence. That could be valuable for very complex multi-step planning. But you will definitely feel that confidence reflected on your invoice. It's a premium price.
Right, the premium bill.
The premium bill, indeed. So kind of summarizing the landscape. For fast, maybe shallower tasks, Gemini 2.5 Flash might win on user experience because it's instant. For nuanced, time-sensitive tasks where value is key, GPT-5 Mini often hits that sweet spot. And for those rare, extremely high-value complex tasks, that's where the flagship GPT-5 really earns its keep. Following that kind of strategic routing pattern is what keeps an AI platform both fast and fiscally sane.
That makes a lot of sense. So if Mini is hitting this sweet spot so well, how do we make sure we're getting the absolute most out of it? What are the key knobs or architectural levers we should be thinking about?
Yeah, there are a couple of main levers the source points to that really change how Mini behaves for a specific task. The first one is called reasoning effort. You'd basically turn this down for simple things like just retrieving information or doing light text transformations. But you'd crank it up when you're dealing with complex puzzles, math proofs, or generating code that has tight constraints.
Okay, so you can kind of dial it up or down based on the task difficulty.
Exactly. And the second lever is verbosity. Pretty straightforward. Keep it low if you want structured output like JSON. Turn it up if you need more descriptive text like narration. And Mini seems to respond quite cleanly and predictably to both of these, which is great for building reliable systems.
Predictability is good.
Very good. And don't forget that long context window we talked about. That itself is a huge lever. It just simplifies so much. You can often skip complex chunking strategies or elaborate RX setups, just paste in the full spec, the database schema, maybe a few good examples right into the prompt. It often just fits.
That saves developer time, too.
Huge time saver. Plus, you get nice developer ergonomics things like streaming outputs for snappy UIs, good controls for getting structured data back, and tool calling that actually works reliably, like having a good coworker, not fighting a flaky system. And then there's caching and batching. Obvious wins. If your product hits the same prompt often, prompt caching pays off big time. Batching requests helps you stay within rate limits, especially for mid-volume jobs. Honestly, the economics of Mini are such that many workflows just fall below that threshold where you're constantly worrying about cost. And that freedom, it unlocks new ideas, things you might have dismissed as too expensive before.
Okay, so given all these capabilities, the levers, the context window, the tool use, what does this mean for actually writing the prompts? Especially for smaller, efficient models like Mini. Are there specific patterns that work particularly well?
Yes, definitely. The source highlights several prompt patterns that seem to show up again and again in successful production systems using models like Mini. First, always put a concise, like two-line mission statement right at the very top of your prompt.
Mission statement.
Yeah, just clearly define what success looks like for this specific task, and maybe explicitly state what the model should ignore. Small models really benefit from that tight framing. Second, always ask for a specific compact JSON schema for the output. And this is crucial. Tell the model that any fields it can't fill must be explicitly set to null. Don't let it just omit things.
Ah, okay, so you force it to be explicit.
Exactly. And then you validate that schema when you get the response back, of course. Third, provide one high-quality example for each potential edge case. Think of them like unit tests, but written in natural language within the prompt.
I like that unit tests in natural language.
It really helps guide the model. Fourth, add a simple verification step right at the end of the prompt. Ask the model to double-check its own output against a simple rule you provide. That one little line can catch a surprising number of silly mistakes, those silent failures. And finally, don't ask the model to do complex arithmetic or database joins. Offload that stuff. Ask the model to plan the steps. Call an external tool, like a Python function or a SQL query executor, and then just report the results back.
Play to its strengths. Let tools do what tools do best.
Precisely. These habits really play to Mini's strengths, its reasoning and planning, without asking it to be a perfect calculator. Plus, building prompts this way makes it much easier if you ever want to migrate parts of the workload down to the even smaller GPT-5 Nano later on.
That's really practical advice. Could save people a lot of headaches down the line. Thinking beyond just the prompt and the first response, how does the speed of Mini impact how users actually interact with an AI feature? How does that latency or lack thereof shape behavior?
Oh, speed is huge. It profoundly shapes how people use things. The Force notes that when an AI response comes back in under, say, 2 seconds, people tend to ask better questions. They ask more follow-ups. They're more likely to review multiple options or results.
You're staying engaged.
Exactly. But once that response time drifts much beyond 5 seconds, people start skimming, they lose patience, they move on. The interaction quality drops off fast. GPT-5 Mini, for most common interactive tasks, seems to consistently land on the right side of that 2-second line. Now, you might still get pauses with really long context windows or if you ask for huge structured outputs, but you can often hide that latency effectively with good UI design, like streaming the response token by token.
Right, optimistic UI tricks.
Yeah. And another speed-related point is its rate limits. They seem pretty generous. It means one team running maybe a heavy internal batch job is less likely to accidentally slow down another team's user-facing feature during peak times. In practice, that means lower bounce rates for your product and fewer of those frustrating oops, try again later messages for your users.
Okay, that's a tangible benefit. We've talked a lot about token costs, but you hinted earlier that token quotes were only part of the story, part of the bill. What about those hidden costs? What's the deal with total cost of ownership, or TCO?
Absolutely. Token prices are just the tip of the iceberg, really. TCO is critical. The source makes an interesting point. Larger, more powerful models can, somewhat ironically, end up requiring more overhead. You might need more sophisticated guardrails around them, more logic for retries, potentially more human review of their outputs. And they can also tempt teams into writing kind of vague prompts just because the model seems like it can understand anything. That can lead to unpredictable behavior.
Right, the magic black box problem again.
Exactly. Smaller models like Mini, almost by their nature, create a healthy pressure to be more explicit. You're kind of forced to write clearer prompts, define stricter output schemas, put stronger validation in place. And while that might seem like more work up front, it generally leads to fewer bugs escaping into production. And trust me, that makes your on-call shifts much, much easier because debugging a simpler, more explicit chain of operations at 2 a.m. is way better.
I can definitely see that. Easier debugging is always a win.
For sure. And there's also the opportunity cost aspect of TCO. When your default model is cheap and fast, like Mini, it encourages a different kind of culture, a culture of trying more ideas. Some of those ideas will inevitably fail, and that's okay. It's cheap to find out they fail. A culture of rapid, low-cost experimentation almost always beats a culture of planning these huge, expensive, big bang releases that inevitably slip for weeks or months.
Yeah, faster iteration cycles.
Exactly. Mini encourages that faster cycle, more frequent updates, more use of feature flags, less drama around big launches.
Okay, so Mini seems to have a lot going for it in terms of value and TCO. But what about the potential downsides? We hear about the benchmark trap. Are there other risks or pitfalls developers really need to watch out for?
Yeah, it's important to be realistic. Benchmarks are useful guides, but they are definitely not the whole world. That's the benchmark trap. One specific risk the source mentions is data leakage. Some of these public benchmark datasets are so well known, parts of them might have inadvertently ended up in the model's pre-training data.
Ah, so the model might have seen the answers already.
Sort of, yeah. It can artificially inflate the benchmark scores and mask real-world weaknesses on problems the model hasn't specifically seen. So the advice is, blunt that risk by running your own private tests. Mix fresh, unseen problems of samples of your actual production data, and critically measure the failure modes that actually matter to your application. Is it slipping up on numbers? Is it missing constraints you specified? Is it misinterpreting diagrams or charts?
Focus on your specific pain points.
Exactly. And while Mini generally performs well, it can still make mistakes, sometimes confidently. So always keep that verification step in your prompt, and definitely use tool calls for anything involving arithmetic or precise data extraction. You'll sleep better.
Good advice.
Another trap is benchmark saturation. What happens when multiple models all start scoring near 100% on a benchmark?
the scores become less meaningful.
Right. Small differences between, say, 98.5% and 99% are often just statistical noise at that point. When a benchmark gets saturated like that, your decision on which model to use should swing much more heavily towards other factors. Cost, latency, maybe refusal rates, how often the model just says, I can't answer that. The nice thing about Mini is that even when benchmark scores get very close at the top end, its strong economics, the low cost per correct answer, often still make it the most compelling choice. That combination of strong benchmarks and strong economics, that's actually quite rare, and it's really the core of its value proposition.
This has been incredibly helpful in understanding the nuances. So let's try to bring it home for the listener. Based on everything we've discussed, when should GPT-5 Mini be the absolute go-to default choice for starting a new feature or tackling a task?
Okay, the rule of thumb emerging from the source is this. Start with GPT-5 Mini when 1. Your task has a tight, clear definition. You know what success looks like. 2. Your application needs to feel responsive, ideally getting answers back in a few seconds. And 3, critically, when every cent you spend per request actually matters to your budget.
Okay. Tight definition, fast response, cost matters.
Exactly. Think about typical use cases. Routing support tickets accurately, generating answers from a knowledge base, cleaning up messy data, maybe curating research notes, extracting tables from PDFs, fixing small code snippets, doing content moderation based on clear, established policies. These are all great candidates. And remember, you can always augment it. Add small, focused tools if it struggles with specific things like math or parsing a weird CSV file. And always keep the big GPT-5 flagship ready as an escalation path, just for those really thorny, complex edge cases that Mini can't quite crack. This tiered approach gives you a platform that's fast, accurate, and honestly, in the best possible way, kind of boring and predictable, which is what you want in production.
Boring is good when it means reliable and cost-effective. So conversely, when do we know we absolutely need to reach for something else? When is Mini not the right first choice?
Right, there are definitely times to look elsewhere. You'd probably read for the full GPT-5 flagship right away for really complex creative work, writing long-form original content, maybe, or for deep, complex code refactoring tasks, or wide-open exploratory research where squeezing out every last fraction of a percentage point in accuracy really might matter more than the cost.
Okay, the high-end, complex stuff.
Exactly. You might consider Grok 4 if your primary need is that very long-chain reasoning capability we mentioned, and if the premium price tag isn't a major blocker for you. You'd lean towards Claude Sonnet 4 if the absolute top priorities are nuanced tone control and meticulous following of very complex instructions, perhaps more so than raw reasoning on benchmarks like AIME or math. Gemini 2.5 Flash is clearly the go-to when you need near-instantaneous summaries or extractions at massive scale, and you can tolerate slightly lower accuracy on pure reasoning tasks.
Speed is the absolute king there.
Speed is king. And finally, GPT-5 Nano is perfect for embedding into background processes. Things like tagging incoming events, enriching log data in real time, scoring simple patterns tasks that happen behind the scenes and don't need instant results. The key takeaway across all of this is that intelligent routing between these different models is what saves you money without significantly hurting the quality of the user experience.
That makes perfect sense. Let's just put a fine point on the money aspect. What's the literal bottom line on price when it comes to using Mini at scale?
Okay, money, plain and simple. The output token price for GPT-5 Mini is low enough that running millions of daily answers through it is entirely feasible. It doesn't break the bank. And if you add prompt caching, especially for your most frequent user queries, your input token costs can drop significantly too.
So both sides of the cost equation look good.
They do. The price for the larger GPT-5 model still feels fair for those really high-value, complex runs, but the crucial point is it doesn't have to carry the entire load of your product anymore. This tiered pricing structure across the GPT-5 family, Nano, Mini, Flagship, allows for that clean split we discussed between high-volume interactive traffic and background tasks. And that split, it makes capacity planning much simpler, and it genuinely takes a lot of the drama out of those quarterly budget review meetings. It becomes predictable operating expenditure.
That predictability is gold for any team lead or manager. Okay, last practical question. For teams who are listening and are already running systems, maybe on older models or different platforms, what's your best, most practical, from-the-trenches advice on migrating workloads onto GPT-5 Mini effectively?
Right, migration. Always trickier than starting fresh. Here's a practical sequence based on the source and general best practices. First, start by sampling your real, live production traffic. Get a representative set of requests. Then, set up mirroring. Send a copy of those requests silently to GPT-5 Mini in parallel with your current system. Next, you need to score the outcomes. Compare Mini's responses to your current model's responses, or ideally to a ground truth if you have one. Log any disagreements or failures. Now here's a critical step. Focus on fixing your prompts first. Iterate on the clarity, the examples, the schema definition before you jump to tweaking model parameters or deciding Mini won't work.
Optimize the instructions before blaming the model.
Exactly. If you see consistent errors like math mistakes or trouble parsing specific formats, then add a targeted tool call to handle just that part. Don't try to make the prompt do everything. Once your prompts are tuned, run that cost per correct answer analysis we talked about. Use your benchmark results to set clear data-driven thresholds for when to route traffic to Mini versus maybe keeping it on the old system or escalating to GPT-5.
Use your own data.
Use your own data. Then start the actual migration small, carve out a narrow slice of production traffic, maybe 1% or 5%, and route it to Mini. But crucially, keep a kill switch handy so you can instantly revert if things go wrong. And monitor closely. Track latency, error rates, refusal rates, specifically for the traffic going through the Mini route. Expect a few bumps in the first week, learn, adjust. This kind of steady measured migration pattern is how you turn those promising benchmark numbers on a slide deck into durable real-world improvement without causing chaos.
That sounds like a solid, low-risk approach.
And one more thing on that, don't skimp on observability. It's absolutely key. Log your prompts, the model's outputs, any tool calls, and the results, obviously. Do this with privacy considerations firmly in mind, scrubbing sensitive data. Sample some conversations periodically for manual review. Just read through them, see if they make sense. Track your refusal rates, track schema validation failures, build a simple dashboard, maybe showing cost per correct answer broken down by different routes or task types over time. Why? Because when those metrics start to drift, you want to notice it before your customers do.
Catch problems early.
Catch them early. Mini's good economics actually make this discipline pay off visibly, because improvements in your prompts or routing often translate directly into noticeable cost reductions you can see on that dashboard. And just a final quick word on evaluation hygiene, building on the benchmark trap idea. Never, ever let public benchmarks completely replace your own internal testing suite. Build a small set of tests that specifically capture your domain, your common failure modes, your data formats.
Tailor to your reality.
Exactly. Keep that test suite private. Update it frequently as your product evolves. Track not just accuracy, but also things like refusal rates, hallucination tendencies, and whether the output actually conforms to the schema you requested. Run that suite across all the contenders: Mini, GPT-5, Gemini, Flash, Claude, Grok, Nano. Then make your model selection and routing decisions based on your numbers from your test, not just based on someone else's generic spreadsheet published online.
Trust but verify with your own data. Excellent point.
So, after digging into the source and thinking about my own experiences building with these models, my conclusion aligns pretty closely with the article's thesis. GPT-5 Mini really feels like the default choice for getting real work done right now. It's the model you reach for when you genuinely want to ship something useful, something that improves a user's life, like this week, not next quarter. It keeps your app feeling snappy, it keeps your budget predictable, it plays nicely with external tools and retrieval systems, and it scales up without a ton of complex ceremony. You could genuinely build a very solid product line primarily on Mini, keeping the big flagship model in reserve for only those truly exceptional cases that demand its absolute maximum power.
So that tuned hatchback really delivers day to day.
It really does. I mean, is it the absolute best value for every single team and every single task? Maybe not absolutely universally, but for a huge range of common use cases. That mix of accuracy, speed, and price is just incredibly hard to argue with right now. Its benchmark performance seems to genuinely reflect its real-world behavior, which isn't always the case. Its price point turns potentially scary AI bills into manageable, steady operating costs. And the whole GPT-5 family pricing structure encourages that smart routing. Nano invites you to offload background work. Rivals like Gemini, Flash, and Claude Sonnet 4 definitely have their clear strengths and roles too, and you should absolutely use them when they're the right fit for the job. But ultimately, value isn't about sticking to one brand. It's about the outcomes you get for the resources you spend. And on that practical scoreboard, GPT-5 Mini just keeps putting up winning numbers for a lot of teams.
That's a fantastic summary. So if you're listening and looking for a simple rule, a heuristic that will likely hold up well under pressure, maybe try this. Start every new AI feature development effort on GPT-5 Mini by default. If you find the model stumbles specifically on things like math or complex data parsing, just add a focused tool call to handle that bit. Don't throw the baby out with the bathwater. Only consider moving a slice of traffic up to the full GPT-5 flagship when your own cost per correct answer analysis using your data explicitly tells you the value trade-off demands it. And definitely look for opportunities to fold the even cheaper GPT-5 Nano into your background jobs, your logging, your observability layers. Now, here's a final thought to mull over.